Hello, hi, I'm Hoche. Welcome to my channel. Welcome to my home. I have a Bryston 4Be. One channel has blown output transistors and a barbecued preamp board. One cool thing about these amps, they're modular. You can take them apart rather easily. You can actually swap one channel for another. It helps you troubleshoot. So in this case, the bad board is so cooked that I'm actually gonna use the good board to look at the components that I will need to rebuild the bad board. Here's the output board. The video doesn't do justice to how bad this looks in person. I mean, it looks really bad in person. See over here, this whatever was here is completely gone. Look at this. We have a barbecued board. Look at this, you can see the inside. You can see the inside of this guy. I've never seen a board like this. Usually, you know, the output transistors are blown and they create a short. It pops the fuse and that's it. I never actually seen a board this damaged, but I think I have the forensics here. This is the test points where you measure the bias across these two pins with your multimeter and you set them to, I think it's like 6 millivolts or 12 millivolts, whatever the service manual says. I'll adjust it to. Taking a closer look over here. This melted, the tips melted. So somebody worked on this amp. So I believed, or a technician with a shaky hand or something, caused a short circuit. I'm going to replace all these parts, and the output transistors are shorted. So I'm going to replace the output transistors and all these parts and these electrolytic caps and see what happens. You know, I got to test all these transistors in this board because you know, there's some parts are obviously damaged, but there's also parts that get damaged and the damage is not visible. So basically I have to test, you know, check every transistor in this board. Even this pot could be cooked. This is a good board. It's a blessing to have because as you can see, I can't even see what was there. So I'll come to this board and identify the part on this board, on the good board. The good channel helps me troubleshoot the bad channel. Look at that also. There's some damage over here and also where it connects to that board. That board connects right here and look at that. So there could be a bad component on this board. A list of parts and I went to DigiKey and Mouser. Some parts were, you know, cheaper on one website than the other, or some parts Mouser don't have but DigiKey has, and some parts DigiKey has and Mouser doesn't. So let me show you. For example, I have my shopping cart and I have a list of parts and I always get a few more. So it's some of these caps, it's a lot cheaper if you get 50 or if you get 10 instead of 1. So like if you buy only 1, it may be like 50 cents, but if you get 10, they're like 40 cents each. But if you get 50, they're like 30 cents each. That helps. You know, the most common values like 10 microfarads, 47 microfarads, 22, 220, 100, stuff like that. And if it fits, I get higher voltages. So in the future, if I need a capacitor, let's say I need, for example, a 22 microfarad cap, 100 volts. So, you know, I may have it. Maybe I need 63 volt, but if I can buy one that's 100 volt, and it fits, I'll get a few of those, and then in the future I'll have the cap that I need without having to order. Here are the 8 output transistors removed, and I'm going to do a quick test to see which ones are completely short-circuited. If there's a short circuit, it beeps. Okay, let's see. Oh, this one is not shorted. I'll put this one to the right, and this one is not shorted. Oh, I'm surprised. Okay, this one's shorted. 5 were shorted, 3 were not. So to test to see if they're good, if it's an NPN, you put the positive on the base and then you test between base and collector and base to emitter in diode mode, and you get a voltage drop like 0.5 to 0.7. Okay, so this one is okay. So this one, it's a PNP and it's okay. Okay, this one's open, actually. I never see open transistors. Not shorted, but open. That's why it didn't test as a shorted, because it was a different type of failure. Here are the driver transistors that drive the output transistors. So the driver transistors send a preamplified signal to the output transistors to be amplified. Drivers and output transistors are not soldered in. They have sockets, pins and sockets, kind of like vacuum tubes. To remove them and install them, there is no soldering involved. I'm going to remove the board and start changing what I can so that the board is ready when the parts arrive. To clean the heatsink thermal paste, you can use alcohol and paper towels. These are the old mica insulators. So these go between the heatsink to isolate the transistors electrically. I am removing the burned parts from the circuit board. On this part of the circuit board, a trace was completely burned out. I used a piece of copper desoldering wick. I scraped the cover and exposed a bare copper and then put the wick on top and solder it. Another problem with the traces, over here, there's no trace, and on the bottom also no trace. So the easiest thing for me to do at this point is I'm going to take the leg of this resistor that I'm soldering in right here. I'm gonna bend it over and bring it to where it connects. If you look over here, it's been compromised, so I added a nice piece of copper wire. I'm gonna solder it right there in place, and that should be the final circuit board repair. I finished the work on this amplifier board, took all the measurements that I could with a multimeter. So I am now going to apply some thermal grease and install the drivers and output transistors, and plug in the board, the module, and see if I get sound. This is the moment of truth. The drivers that I use are MJ15030G and MJE15031G. The output transistors are MJ15022G and MJ15023G. And of course, I checked, double checked, triple check, and quadruple check to make sure that I got the PNPs and the NPNs in the right locations. Otherwise, we would let out the magic smoke and it would suck. Once I have this installed, as you can see, there is no room for troubleshooting. So if there's a problem, I have to take it out again, probably build a harness. It would be terrible. I have a dim bulb and a 1 kilohertz test tone. I am ready for testing. I am nervous. I hope it works. Fingers crossed. Yes! Woohoo! It's ready. It sounds, that's a clean wave. Absolutely fantastic. If you like this video, please like and subscribe. I would really appreciate it. Okay guys, I'm adjusting the bias. The adjustment, it's this knob right here. Counterclockwise makes it go down, clockwise makes it go up, about 6. All right, and that's how you do it. If you have DC voltage at the speaker's output, you bring it down to 0 at this adjustment over here, the blue adjustment over here. Counterclockwise brings it down, clockwise brings it up. You want to bring it to 0. Okay, now it's kind of oscillating around the 0. That is just perfect. And as you can see, we have absolutely perfect, beautiful sine waves on the oscilloscope. Both channels perfectly matching. So we're in business. Hello. And finally guys, the most important test in the world, the listen test. I've been listening to this amplifier and I love it. I love the bass. Really has a grip on the woofer. It is very smooth, silky, great sound stage, you know, really good amplifier. I hope you enjoy watching this video. If you did, please smash the like button, like and subscribe. I would really appreciate it. Thank you very much.